Let's continue our studies by focusing on the network time protocol implementation within Red Hat Enterprise Linux. We'll launch a shell and open our notes and begin discussion momentarily. Let's maximize gedit. And we'll label this section Network Time Protocol Implementation. The acronym for Network Time Protocol is NTP, and it features the ability to synchronize your system's clock, and it optionally features the ability to synchronize other clocks. Also can be used to sync other clocks, providing that those other clocks, regardless of device type, whether an infrastructure system such as a router or firewall, or even an operating system such as Windows, FreeBSD, or Linux, or Solaris, so long as network time protocol support is built in or included by way of a daemon or service, and the version of network time protocol works with the version implemented by Linux, which is version 4 and older, such as version 3, 2, and even the older versions of the protocol, then the client contacting your server will be able to synchronize their local clock. So with that said, how is it implemented on the system? From the shell, again, it hasn't changed from the implementation with Red Hat Enterprise 4 or even 3 or Red Hat 9 for that matter. What has changed is the version of the package that's used to implement NTP. From the shell, an RPM query all grep NTP reveals the name of the package momentarily, and its version 4, major version, minor version .2. NTP came up in this path as well. An RPM query list of NTP enumerates its contents as expected. We'll scroll up towards the top, where you'll see it maintains an etc NTP directory, and ntp.conf. This is the main configuration file. So let's just note this implemented as ntp 4.2.rpm package, and the etc ntp.conf is the primary configuration file. So when you've determined that you want to synchronize your clock against other systems or turn on, let's say, the signature feature, you'll do so through the etc ntp.conf file. Another feature is that NTP works based on a hierarchy, so is hierarchical, using stratum, or strata that is, various stratum levels, but using strata levels to dictate or to influence or to denote accuracy, and that is clock or time source accuracy, which we need to talk about before we get into the main configuration file. So let's label this section or subsection NTP strata, and what you basically have is the ability, let's just bring this back in, the ability to denote clock accuracy based on stratum, with stratum level 1 being the most accurate, as an NTP server at this level is connected to an external time source. And the protocol provides the utilities necessary to determine the various strata. And an external time service includes, but not limited to, GPS, radio, etc. So NTP has this built-in hierarchy called NTP strata, and each clock in the NTP strata registers its stratum level depending on what source it is using to obtain its time information. So if our clock uses a stratum 2 level clock, then our clock or our server becomes a stratum 3 time server, so on and so forth. If we are at stratum 5, or if we authenticate against a stratum 5 clock, then our clock will become a stratum 6 clock. If we authenticate against a stratum 1 clock, our clock becomes a stratum 2 clock. So the hierarchy is very easy to understand, and you should aim to synchronize your clock against low-level stratums such as 1 or 2 to ensure accuracy. But the variation across strata is so small it's measured in milliseconds, which means your accuracy will be high, relatively speaking, anyway. So if you decide to authenticate or get your time source synchronized against a time source that's at stratum 2 or 3, you won't be terribly off from stratum 1 or even 2, depending on the level that you authenticate or synchronize your time source at. Now, regarding those various strata levels that you may synchronize your clock against, you can find resources, public NTP resources, by navigating to www.ntp.org. So use ntp.org to locate public NTP clocks at various strata. But before doing so, we should also note that by default, NTP is not enabled, and we need to enable it. Let's just take a look at the shell to determine whether or not it's enabled. We'll let you in as a root user, and once in, we'll execute a service NTP, and again, it's the way it's listed, just so you don't have to memorize it. In etc initd, NTP is listed as NTPD, so there'll be a service NTPD status. This will tell us whether or not it's running. Also, since we now know how to use checkconfig list NTPD reveals that it's turned off in all run levels. So our clock, our local clock, currently does not synchronize against an NTP server, which means when you execute date, the time that's returned, the date and time that's returned, is based on the time that's set in the BIOS and the time that you set up during installation of Red Hat Enterprise Linux, which may or may not be tied to the BIOS, but it's derived initially at least from the BIOS. Whether or not the OS controls the BIOS is a separate question. But nonetheless, this time source is local and not remote. And again, to ensure that your operating system is time-wise synchronized or as close as possible to what is known and accepted as standard time, as governed by the Network Time Protocol, you need to configure your NTP instance, the NTPD instance, to synchronize against remote time services. Now again, the time service doesn't have to be an internet time service. We've got in our environment a time server. Let's just navigate to our graphic and identify that server, which we can use. This is the classroom topology. For the time being, we can choose to synchronize against our Linux CBT Media 1 box. That's this box here, the 75100 box, as it's running NTP. Just to illustrate how NTPD works. To do so, we need to include, so our first task is to sync against internal NTP server. And to do so, we'll modify etc ntp.conf with the following entry: server followed by the IP address or name, hostname if hostname is resolvable, of the NTP server. Its IP address is 168.75.100, but if, again, DNS is in order, or if the etc hosts file has an entry, it would suit us to use the name. In the event that the IP address changes, it would then render us with one less change. We would not have to update the NTP configuration file. So let's go ahead and paste this directive in the primary NTP configuration file located in etc ntp.conf. Notice that there are some server lines defined to connect to Red Hat Enterprise Linux servers at pool.ntp.org. That's for this local system. How about for our remote system? Let's see what's configured. We'll open another shell and SSH as root to 75.199, which is running the 5.1 release, and see what it's configured to do, and then make the determination as to which one to modify. This server doesn't appear to have any server lines enabled. In fact, it has an internal server line enabled, this remote system. So here's an example of a remote system which authenticates, or synchronizes that is, against an internal network time protocol server. We can include a comment, internal NTP server. And there's an entry for the loopback adapter in the event that NTPD is started with no reference to an external or other time source that's more accurate than the local system. NTPD will work against the local clock, and it will use it as a time source if nothing else is indicated. Now on the remote system, let's execute service NTPD status to see whether or not it's running, and as you can see, it's stopped. Also, check config NTPD shows that it's stopped. So with that said, let's start the NTPD service. To do so, simply execute. So step B is to execute service NTPD start, and this starts the NTPD service. And then we'll also execute for subsequent reboots of the system check config NTPD on, which will turn it on. Let's go ahead and copy and paste this. And we'll do this on both systems to ensure that the clock is running on both. So this starts the daemon, and then let's execute check config NTPD on, and now it's going to be set to start in the appropriate multi-user run levels 2 through 5. So how do we go about confirming whether or not NTPD is up and running? Well, once it's up and running, we'll list as step D, use NTPQ NP. This queries the running NTPD server, and it returns status information including whether or not the local NTPD server has synchronized against a remote NTPD server, and whether or not it has contacted all of those NTPD servers, one or more of course. So there we've executed NTPQ-NP.